Going over a couple more examples here with each of the theorems. So on number 4, you want to verify that triangle RST is similar to triangle XYZ, and then also find the scale factor between the two triangles. If I wanted to verify that the two triangles are similar since we're given each of the side lengths, then we need to make sure each of the ratios of the sides are the same. So side RS, if I look at the similarity statement, has to correspond with XY. Side ST corresponds with YZ, and then side TR corresponds with ZX. So 12 over 28, that has to be the same as 15 over 35, which also has to be the same as 24 over 56. I can verify that these two triangles are similar just by dividing each of those ratios. You don't need to simplify in order to verify that the two triangles are similar. If you divide 12 by 28, you get about 0.43. Same as if you divide 15 by 35, and then 24 divided by 56 is also about 0.43. So that verifies that the two triangles are similar because all of the sides are in proportion. Then to find the scale factor of triangle RST to XYZ, XYZ actually has to go in the numerator. So I can just take the reciprocal of any of these, like 28 over 12. That's a scale factor. However, since it's a fraction, I do want to simplify it. So I can divide each of these. I can divide them by 2, but then that's actually not the greatest common factor. The greatest common factor between 28 and 12, if I want to simplify that in the least amount of steps, is 4. So 28 divided by 4 is 7. 12 divided by 4 is 3. Okay. So the scale factor should be 7/3. And then on the last example that I'm going to go over with you, number 5, because 6 is kind of the same as number 5, the shortest side of a triangle similar to triangle ABC is 15 units long. So if I draw a triangle, it's going to be bigger, even though my triangles might appear to be somewhat congruent. You could label it whatever you want. You don't even have to label it. I'm going to label it triangle PQR. But the shortest side of that triangle is 15 units long. That has to correspond with the shortest side of triangle ABC. So that would be side PQ, the way that I labeled it, because 6 is the shortest side in triangle ABC. Find the lengths of the other sides of the triangle. So I want to find the length of QR and PR. I'm just going to use single variables, X and Y. So I could set up a proportion in order to find first the length of X. You could find Y first if you wanted to, but 6 over 15, a side in triangle ABC over a side in triangle PQR. So when I set up my proportion, everything has to match up. Side in triangle ABC has to be in the numerator. If I'm trying to find X first, 7 corresponds with that. So 7 over X. And then in order to solve this for X, I can cross multiply 7 times 15 and then divide that by 6. So we end up with X is 17.5. Or side QR is 17.5. And then I could do something similar to find the value of Y or side length PR. So I could use 6 over 15 again. You could use 7 over 17.5 if you want. You should get the same thing. But if I set up 6 over 15, then that would equal 9 over Y. Maybe some of you are thinking, well, I could set up 15 over 6, then that would equal Y over 9. You get the exact same thing. But here I can cross multiply 9 times 15 and then divide that by 6. So 9 times 15 and 135 divided by 6, then Y or side length PR is 22.5. So the side lengths are 17.5 and 22.5.